Welcome to Lecture 3.2, Solutions to Linear Equations in Two Variables. In our last lecture, we chatted about plotting ordered pairs, and now we're going to move on to linear equations. Linear equations, as you can imagine, deal with lines. So let's take the instance of where we have one variable, and you've already done this, a linear equation in one variable. There are examples like 3x minus 2 equals 10. And so you solve for x and x equals 4. So you graph the solution set and it's a dot on 4. X plus 5 equals 7. Solve for x and x is 2. You plot it and you have a dot on 2. 2x equals negative 6. X equals negative 3. So you graph it and you have negative 3, a dot on negative 3. Now that's great when we're working with one variable, but we're moving on. We're getting a little bit more sophisticated about math, so we're moving on to two variables. So what does a linear equation in two variables look like? Well, it looks like something like 2x plus y equals 3. Now I can't tell you just to solve for one of the variables because it's kind of meaningless unless I give you some more information. So what if I say x is 2? Well, when we plug it in, 2 for x, I have 2 times 2 plus y equals negative 3. So y must be negative 1. Okay? And we can verify that, yes, indeed, y would be negative 1. 3 equals 3. Let's try if I tell you x is 0. We'll plug in x for 0. Well, 2 times 0 is 0, so y equals 3. Let's just verify. When x is 0, then y is 3, so 2 times 0 is 0 plus 3, it does equal 3. So another solution is 0, 3. Let's try another one. So what if I told you x is 5? Well, then y, you solve for y, and that equals negative 7. So the pair is 5, negative 7. For 2x plus y equals 3. When I tell you x is 5, the solution to y is negative 7. But as you see, depending on what x is, there'll be an outcome for y. And in fact, there's an infinite number of solutions. I can tell you, okay, what's when x is negative 1/2 or 1.34759? There will be a corresponding y to go along with that. So there's an infinite number of solutions, not just 3, not just 4, not 5, but an infinite number. They're not countable. So let's think of another linear equation, 2x plus 3y equals 6. And let's figure out what the corresponding coordinate is if I give you one of them. Solve for the other one. So when x is 0, we're solving for y. So let's plug in wherever we see an x. 2 times 0 plus 3y equals 6. 0 plus 3y equals 6. So 3y equals 6. Divide by 3. So y equals 2. So the ordered pair is 0, 2. Let's plug in the next one. X, 1. We're looking for x given y. Wherever we see a y, we're going to plug in a 1. Do the math down until we find x. X equals 3/2. So let's plug a 1 in here. We have 2x plus 3 equals 6. Subtract 3 from each side. 2x equals 3. Divide by 2. X equals 3/2. So our solution set is 3/2, 1. Let's try our last one of 3y. So if it's 3y, then x is 3. Plug in 3 wherever we see an x. 2 times 3 plus 3y equals 6. Subtract 6 from both sides. 3y equals 0. Therefore, divide by 3, y equals 0. So our solution set is 3, 0. Sometimes it's a little bit easier to given a table and we fill in the blanks for a table. So I'm going to go ahead and reveal this whole entire problem. And I'm given the blue numbers, and I have to find the green numbers. So let's walk through this. For 0 and y, because I don't know what y is, I plug in a 0 wherever I see an x. So 2 times 0 minus 5y equals 20. Negative 5y equals 20, therefore y equals negative 4. Negative 4. When y is 2, what's x? In the 2x minus 5y equals 20, let's plug in a 2 for y. 2x minus 10 equals 20. 2x equals 10, therefore x equals 5. When y equals 0, we plug it in, and we get x equals 10. And I encourage you to work these out yourself. When x is negative 5, plug in for x negative 5. What do we get for y? So negative 10 minus 5y equals 20. Add 10 to both sides. Negative 5y equals 30. Y equals 6. So let's complete the following table for the equation of y equals 2x plus 1. Same kind of procedure. So my first one is 0, comma y. I'm looking for y. So y equals 2 times 0 minus 1. So that's y equals negative 1. Zeros, I always like zeros because they're fairly easy. Next one, our x is 5 and we're still looking for y. So y equals 2 times 5 minus 1, which is y equals 10 minus 1. So y equals 9. Now we're looking for x, but y is 7. So y is 7. 2 times x minus 1. We're going to add 1 to each side, so 8 equals 2x. Divide by 2 on each side, so x equals 4. And yes, I know I flipped it, but that's legitimate. I can do it either way. So it is a 4. Let's plug in x, comma 3. Wherever we see y, we're going to plug in a 3. 3 equals 2x minus 1. Add 1 to each side, so 4 equals 2x. Divide by 2, so x equals 2. So here's another type of way we can ask questions. Is I'm giving you a linear equation, and I give you some ordered pairs, and I ask you which ordered pairs are a solution to y equals 3x plus 2. Well, what we do is we just plug in the values and see if indeed it's true. So y is 3 equals 3 times x, which is 2 for the ordered pair of 2, 3, plus 2. I'm going to leave the 3 alone. I leave the left and right sides of the equation on the same side. I'm not going to move anything around. Just bring it down and see if it's true. 3 equals 6 plus 2. 3 does not equal 8. Therefore, 2, comma 3 is not a solution. Let's try 1, comma 5. So the y is the 5. 3 times 1 plus 2. 5 equals 3 plus 2. And indeed, 5 equals 5. So that's a good solution. That is indeed a solution. Let's try negative 2, negative 4. So y is negative 4. 3 times negative 2 plus 2. That's negative 4 equals negative 6 plus 2. And negative 4 equals negative 4. Yes? 2 out of the 3 were solution set. So that's it for this video. So until next time, be seeing you.